Hi everyone. I hope you're all doing well and that all of you are fine. Today's topic is about plastics, how this material came into existence, and how it gradually shaped our modern world. Plastics are so common today that we almost forget they are one of the most recent revolutions in human history. They are in our clothes, our homes, our vehicles, our medical devices, and even in outer space missions. But plastics did not exist in ancient civilizations. People relied on natural materials: wood, stone, clay, bone, ivory, and metals like copper, bronze, and iron. Early substitutes that acted like plastics came from nature itself. For example, ancient Mesoamericans harvested latex from rubber trees and used it to make rubber balls for ceremonial games. The ancient Egyptians used natural resins and shellac as coatings and adhesives. These materials had plastic-like qualities, but they were limited, rare, and often fragile. The turning point began in the 19th century. Industrialization increased demand for strong, cheap, and flexible materials. Ivory was heavily used for combs, buttons, and billiard balls, but elephants were being hunted at alarming rates. Inventors started searching for artificial replacements. One of the earliest breakthroughs came in 1856 when Alexander Parkes, an English inventor, created Parkesine. It was made from cellulose, a natural substance in plants, and treated with chemicals like camphor. Parkesine could be molded when heated and hardened when cooled. Was the world's first man-made plastic, but it was brittle and expensive, so it never reached large-scale use. Soon after, in 1869, John Wesley Hyatt, an American inventor, improved on this idea. He developed celluloid by mixing cellulose with camphor. This was flexible, moldable, and much cheaper than ivory. Celluloid was used for billiard balls, piano keys, combs, and photographic film. This was the first time a synthetic substitute began replacing natural resources on a global scale. It is fascinating to think that the first plastic was born out of necessity to save animals like elephants, showing how human needs often drive innovation. Before we move to our today, I want to say that this channel is user-friendly. No offensive content, no misinformation. We explain things with respect, curiosity, and authenticity. The story of plastics did not stop with celluloid. In fact, the late 19th and early 20th centuries became a race to discover new synthetic materials that could meet growing industrial demands. One of the most important inventions came in 1907. When Belgian-born chemist Leo Baekeland, working in New York, created Bakelite. This was the first fully synthetic plastic, made by combining phenol and formaldehyde under heat and pressure. Unlike celluloid, which still relied on natural cellulose, Bakelite had no direct natural base. It was entirely human-made, marking a new era in material science. Bakelite was heat-resistant, non-conductive, and could be molded into countless shapes. Because of these properties, it became the material of 1,000 uses. It was used in electrical insulators, radio casings, kitchenware, buttons, telephones, and even jewelry. Collectors today still admire vintage Bakelite items for their durability and Art Deco designs. By the 1920s and 1930s, the world was entering what historians now call the polymer age. New chemical discoveries allowed plastics to be tailored for specific needs. In 1920, German chemist Hermann Staudinger proposed the revolutionary idea that plastics were made of long chains of molecules called polymers. This theory, once debated, laid the foundation for modern polymer science. Staudinger would later receive a Nobel Prize for this insight. Soon, more plastics arrived, each one shaping different industries. In 1927, polyvinyl chloride, PVC, became popular. It was durable, weather-resistant, and easy to mold. PVC was used in pipes, flooring, and cables. In 1933, chemists at Imperial Chemical Industries in Britain accidentally discovered polyethylene. At first, it was unstable, but improvements made it stronger and more versatile. During World War II, polyethylene was used to insulate radar cables, giving the Allies a crucial advantage. Meanwhile, in the 1930s, American chemist Wallace Carruthers, working at DuPont, developed nylon. This synthetic fiber was light, strong, and elastic. It was first used in toothbrush bristles, then famously in women's stockings, which sold out instantly when introduced in 1940. But during the war, nylon was diverted for parachutes, ropes, and military gear. What is remarkable here is how plastics moved from substitutes for natural materials to completely new materials, with properties nature itself did not provide. Plastics were no longer about imitation, but about innovation. By the time World War II ended, plastics had proven themselves as essential wartime materials, and soon they would flood everyday life in peace and prosperity. After World War II, plastics were no longer seen as rare materials for military or industrial use. They began to enter homes, schools, and workplaces at a massive scale. The 1950s are often called the plastic boom era. Factories shifted from wartime production to consumer goods, and plastics made everything cheaper, lighter, and easier to mass produce. Polyethylene, once used for radar insulation, was now found in squeeze bottles, plastic bags, and kitchen containers. PVC became the backbone of plumbing, window frames, and medical tubing. Nylon, previously in parachutes, became everyday clothing, carpets, and even fishing lines. In 1954, Italian chemist Giulio Natta and German chemist Carl Ziegler developed new catalysts that created polypropylene. This material was light, durable, and resistant to heat. It quickly spread into car parts, furniture, and reusable containers. Polypropylene is still one of the most used plastics today. At the same time, polystyrene gained popularity for packaging and insulation. Its foam form, known as styrofoam, made shipping delicate items possible and provided affordable insulation for homes and offices. The invention of polyester further expanded synthetic fibers. It was wrinkle-resistant, quick-drying, and ideal for modern clothing. By the 1960s and 70s, synthetic textiles were dominating the fashion world, offering low-cost alternatives to cotton, silk, and wool. The appeal of plastics was not just their versatility, it was also the promise of a modern lifestyle. Advertisements of the mid-20th century showcased shiny plastic furniture, colorful toys, lightweight luggage, and kitchen appliances that symbolized progress and convenience. Plastics also transformed healthcare. Disposable syringes, blood bags, catheters, and sterile packaging improved hygiene and reduced infections. For the first time in history, doctors could rely on materials that were cheap, safe, and mass-producible for patient care. Even space exploration depended on plastics. Spacesuits, helmets, insulation layers, and lightweight components in rockets all used advanced polymers. Without plastics, sending astronauts beyond Earth would have been nearly impossible. By the 1970s, global plastic production had surpassed tens of millions of tons annually. It was clear that plastics were not just materials of convenience, they had become the backbone of modern civilization. Yet this rapid rise was also planting the seeds of a future challenge, because durability, the very strength of plastics, meant they did not simply disappear. By the late 20th century, plastics had become so common that people rarely thought about life without them. From toys to medical implants, from packaging to electronics, plastics were woven into every aspect of modern society. But this success came with consequences. The very qualities that made plastics valuable, strength, lightness, and resistance to decay, also made them persistent in nature. Unlike wood or paper, plastics do not easily decompose. A plastic bottle discarded today might remain for centuries. In the 1980s and 1990s, scientists and environmentalists began raising concerns about plastic waste, pollution in oceans, and harm to wildlife. Photographs of seabirds with stomachs full of plastic pieces and turtles trapped in plastic rings sparked global attention. Still, innovation continued. Recycling systems were introduced, though uneven across countries. Biodegradable plastics, made from cornstarch or other plant materials, were developed as alternatives. Researchers also explored chemical recycling, breaking plastics back into raw molecules for reuse. Meanwhile, industries pushed plastics further into advanced technologies. Carbon fiber reinforced polymers gave aircrafts and cars strength while keeping them lightweight. Medical science used plastics for artificial joints, heart valves, and prosthetics, changing millions of lives. In the 21st century, global plastic production has exceeded 350 million tons annually. Plastics are in smartphones, solar panels, wind turbine blades, and protective equipment. During the COVID-19 pandemic, plastic masks, shields, and gloves became vital for safety worldwide. The story of plastics is both triumph and challenge. It is a triumph of human creativity, turning simple molecules into materials that reshaped civilization. But it is also a challenge, a reminder that every invention carries responsibility. The rise of plastics shows us that human progress always comes with choices. How we manage plastics today will shape the future of our planet tomorrow. All the information we provide comes from verified historical sources, including books, records, and archaeology. Sources include Susan Frankel, Plastic, A Toxic Love Story, 2011, Jeffrey Meikle, American Plastic, A Cultural History, 1995, and Scientific Archives from the American Chemical Society and Royal Society of Chemistry. Like and share and subscribe to our YouTube channel, Thrones of Knowledge. And don't forget to press the bell icon to get notified on time. Suggest our next topic in the comment section to make our journey even better.